On March 11, 2011, a magnitude 9.0 earthquake struck off the coast of Japan, unleashing a tsunami that devastated entire communities. But beyond the immediate destruction, this quake did something almost unimaginable. It literally moved the entire planet. Scientists calculated that the Tōhoku earthquake shifted Earth's axis by roughly 10 to 25 centimeters. A tiny shift, but one that's measurable with precision instruments. To understand how, we have to look at the physics of a spinning object and what happens when its mass gets rearranged. Think of a figure skater pulling in their arms to spin faster. As the mass moves closer to the center, the spin speeds up. Earth is always spinning, and its axis, the imaginary line through the poles, is not fixed. It wobbles and drifts naturally. During the Tōhoku quake, an enormous slab of the Pacific plate slid under the North American plate, pushing massive amounts of rock downward toward the core. That downward movement brought some of Earth's mass closer to the center, just like the skater pulling in their arms. As a result, the planet's rotation sped up, not by much, but by a measurable amount. The length of a day shortened by about 1.8 microseconds. That's 1/8 millionths of a second, imperceptible to humans, but recorded by atomic clocks. The shift in the axis was even more dramatic. The quake moved Earth's figure axis, the axis around which its mass is balanced, by about 17 centimeters. This is not the same as the axis that points to the North Star. The figure axis is a physical property of Earth's mass distribution. When a massive earthquake redistributes crustal material, it changes how the planet's mass is balanced, and the axis adjusts accordingly. This wasn't the first time an earthquake had such an effect. The 2004 Sumatra quake, which triggered the Indian Ocean tsunami, also shifted the axis and shortened the day. But the Tōhoku quake was the largest ever recorded in Japan, and its effect on Earth's rotation was one of the most precise measurements ever made. To track these changes, scientists use a network of GPS stations and very long baseline interferometry, a technique that measures the position of distant quasars. These instruments are so sensitive they can detect movements of the Earth's surface of just a few millimeters. The quake also caused the seafloor to shift by tens of meters, and the coast of Japan moved eastward by up to 2.4 meters. All of these movements contributed to the overall redistribution of mass that altered the planet's spin. While a microsecond is meaningless in daily life, the fact that we can measure it tells us how deeply connected our planet's systems are. It's a humbling reminder that even a single event in a single corner of the world can leave a permanent mark on the Earth itself. The next time you hear about an earthquake, remember, it might not just shake the ground beneath your feet, it can nudge the entire planet. Subscribe for more stories like this.